High-tech alloys, automated vehicles, robotics. These aren't always the first things that come to mind for a lot of people when they think about manufacturing.
But with modern materials, precision engineering, and streamlined tech-driven processes, today's world of advanced manufacturing opens up possibilities and career options that may surprise you.
Welcome to our Conics Advanced Manufacturing Hub in Tennessee.
Located just south of Knoxville, this place is chock full of super smart people and state-of-the-art equipment.
It's in places like this that Arconic is taking on some of engineering's toughest challenges with solutions that push the boundaries of what's possible in industrial and automotive design.
Combining innovative thinking with high-tech materials and processes. Hi, I'm Albert.
And I'm Natalie, and we're excited to have you with us as we explore the people and processes of Arconic.
If you've never stopped to think about it, you may not realize that manufacturing touches pretty much every aspect of our lives. Cars,
Toothbrushes,
vending machines,
shoes,
electronics.
None of these would exist if someone hadn't designed and manufactured them.
And sometimes, instead of just making things, companies like Arconic create specialized materials that other manufacturers need to build their products.
That's why advanced manufacturing encompasses such a huge array of skill sets and disciplines. The career possibilities are virtually limitless. Now, if you've already been thinking about what you might want to do when you finish school, that's great. That'll definitely give you a jump start on the future.
Yeah, but don't stress if you're not sure what you want to be when you grow up yet. There's still time to start exploring options now, and doing a self-inventory of your skills and interests is a fantastic place to begin. We'll share some great tools to help with that a little later.
The main thing is to be intentional about where you want to go in life. That means envisioning where you'd like to be and then forming a plan that'll get you there.
Sort of like designing your future self.
Exactly. And just for fun, let's use avatars to help us envision some of the careers and opportunities we'll learn about today.
Whoa, that's us. I feel a little underdressed. Can we add anything to our avatars yet?
Absolutely. I think I'll start my journey with a healthy dose of intellectual curiosity.
Not bad, that's not bad, but I'm going for a growth mindset. See where that takes me.
Sounds good. Where do you want to start?
Whoa, this place is huge.
You could fit 75 football fields under this one roof.
Impressive. Hey, what's the hotline?
I don't know, but let's find out.
My name is Shaquana Moore, and I'm an electrical engineer at Arconic on the hotline for the reversing mills, the 96 and the 120. What's happening at the 120 is at the start of the process, and it takes a bigger piece of the ingot and it starts the rolling process. And then on down the line, you come down to the 96, and it just continues to roll the metal out at each mill. Electrical engineer typically troubleshoots all electrical issues on the line. We also introduce new equipment to the line. We make improvements to the process. We're gonna need to disconnect power to this card right here. Problem solving plays a role every day, or there's always some new improvements that you can make on the line. So you're always constantly thinking about, what can I do to solve this problem, or what can I do to make the process better? Also, I do programming as an electrical engineer. The kinds of things we program on the line, it could be a drive, it could be a motor. We also put other animations on the operators to help them get a good visual of what's going on the line. So when I do programming, you start from literally nothing, and then next thing you know, the operators are using it every day.
Today, I'm going to just show how to do a PLC test program and an HMI test screen. We'll demonstrate that now. So when we hit the stop button, the conveyor will stop, and then you'll see this indicator turn red, and the box will also stop moving on the line. So we're going to hit stop. Then when you hit start again, that indicator will turn green to let you know that the conveyor is back running. And then you'll also see the animation of the box moving down the conveyor.
To be an electrical engineer, you need to be good at problem solving, thinking fast on your feet, some circuitry knowledge, anything power related. Also, network-wise, Ethernet, Profinet, those things like that for communication purposes. A lot of work that we do here involves teamwork. So whether it's my counterpart, which is a mechanical person, or whether it's an electrician that I'm working with, I constantly have to communicate with those people to get things done. Creativity, it comes into play when you're trying to make improvements to the process. And critical thinking, that goes in hand with problem solving, because you have to be able to, do critical thinking to get to the end result. I did have a few mentors in school. My math teacher in high school, she saw what I saw, I guess, the love for math, and she kind of just pushed me to continue to go further with that. The advice that I would give to a high school student, if you're interested in a career in STEM, then I would say ask questions now, start researching now so that you'll get a better idea of what you really want to do. You have the opportunity to do summer internships or co-ops. Definitely take advantage of that. There's so many things that come up each day, and you just never know. And I love that rush. It gives me like an adrenaline rush almost, because you never know what you're going to walk into.
Awesome! I didn't realize electrical engineers can be programmers too. I want to learn more about that.
Me too. And I'm definitely taking her advice about finding internships and joining clubs.
Okay, what should we explore next?
Gosh, I don't know. It's sort of overwhelming. I kind of want to know about all of it. How it all fits together,
Yeah, that would help. And I think I know just the person who can do that.
My name is Bubakar Maiga. I've been with Arconic 13 and a half years. My title is Business Improvement Manager. I have the responsibility of new product development, connecting our multiple production centers and making sure that we get the customer orders right. We design the product according to specs and meet the delivery expectations. So the quality that we produce, that goes into a wide range of markets, but mainly for automotive industry. We also have industrial product that goes into road signs, building and constructions, and then heat and air conditioning units. So it's a wide range of market base. To making sure that we're meeting and adhering to the quality standards that meet the material conformities to the end-use product. So anything that goes onto a vehicle or an airplane, you have zero margin of error. So what you see behind me is our automated guided vehicles. We call them AGVs here. And they serve three purposes for us, right? Number one is the safety. The number of time we have an individual going up and down a truck is highly reduced because it's done by robotic. That's the safety aspect of it. And the quality of the product, they handle it more precisely. So there is a very low chance of errors. So that's the quality of the integrity of the product, maintains it that way. And the productivity, things are getting done where these machines run around the clock. We have operators tied into much more important aspect of the production in taking care of those while these robots do their work. As I went to college and learning about agriculture and manufacturing engineering, I began to get a good sense of what I wanted to do as a career. And that led me to begin here in operations in Arconic 13 plus years ago, and was able to learn and grow as a process engineer, and then becoming a supervisor, moving into the management role. It happened to be a good mix, and that's why I decided to maintain in learning and growing. Over the years, as I attended agriculture and engineering school, I got a degree in that. I went for a second undergrad in getting a Bachelor of Science in Economics. Then pursuing into grad school, I got an MBA with focus on strategic leadership. My work requires technical abilities, business acumen, really good in understanding the accountings, the financials in and out, how the product is made, how much it costs to make, and how much you can sell the product for. Being good with numbers definitely helps. But the technical aspect of the engineering part was definitely a foundation for me, right? So I would absolutely encourage that. Being able to work effectively with people, you have to bring something to the table and build trust and create an environment that fosters that. Listening is a good skill, and it sounds rudimentary, but it's very essential in the ability to learn. So not everything is learned in school, but school basically gives you the foundation to be able to think critically and how to analyze the information and make sound decisions. That's definitely helped in becoming successful as a business improvement manager. In my second year in high school in Mali, We had a vehicle in our garage that my dad had kind of set aside and did not have a good use for. So I had always asked the question what this vehicle was standing here for. No one had any interest in it. So I began changing spark plugs on this vehicle. We elected at one point to take the engine out and do the pistons, piston rings, and everything else. And before we know it, this vehicle was up and running. In the future, as I'm good at fixing things and I feel comfortable in learning how to put things together, it was a career path I was interested in pursuing. Over the years, I've had good mentors that really helped me along the way. I cherish that. I have 4 or 5 mentors at any given time. The earliest you can get a mentor or multiple mentors, the more valuable it's going to be. Listen to them because they have good advice to give.
So he just saw this old, broken down truck and thought, you know what? I'm gonna fix that thing.
Dude's got skills.
That blows me away.
Totally.
Well, I can afford to get better at taking initiative and problem solving too.
Yeah, I want to work on those myself. The thing he made me think most about, though, was working on my people skills, because that affects pretty much everything else.
Perfect. Hey, I have a question for you.
Uh-huh.
How can the same metal in soda cans that we crush and put in the recycling bin be strong enough to use in planes and cars and still protect us human creatures in the process?
Has to be thicker aluminum, maybe?
Well, not exactly. As it turns out, not all aluminum is created the same. That's where alloys come into play. When you combine 2 or more different metals, or mix metals with non-metals, the resulting material is called an alloy.
Certain recipes or combinations give alloys unique characteristics like enhanced corrosion resistance, mechanical strength, flexibility, electrical conductivity. The list goes on and on.
Here at Arconic, they melt aluminum in seriously hot furnaces. We're talking volcano lava hot.
Whoa!
Then they add in a variety of materials: magnesium, silicon, copper, manganese, whatever is needed to create the specific attributes their customers need in the finished product.
Arconic applies a variety of heating and cooling steps as their aluminum is rolled into finished coils that can measure more than 2.5 miles in length, weighing as much as 38,000 pounds.
These coils will ultimately be used around the world to make a host of industrial products, as well as cars, trucks, passenger planes, even jet fighters.
Bet you didn't know strong, lightweight aluminum has been a part of aviation from the beginning. The Wright brothers used an aluminum alloy to build the first airplane engine in 1903.
Let's take a closer look at how these alloys are tested at Arconic's Tennessee operations.
My name is Laurel Black. I work at Tennessee Operations Arconic, and my role is Quality Lab Coordinator. I ensure that the quality is preserved for the process and that we are getting the customer exactly what is safe and up to industry and customer specs. First, we would test the chemistry, and that would be using the spectrometry machines. You would take a small puck that would be representative of the ingot, and you would check the chemistry of that to make sure it is what we're aiming for and what the customer wants. This is a sample from an ingot that we have. This is from a scissor sample mold, so that's why it looks this way. We use it to measure the chemistry of the ingot as it's casting, also before it's casting, just to make sure it's the correct chemistry that we're looking for. The bin tester is helpful for testing the ductility of the metal that we're looking for. We ensure that the hot rolling or the cold rolling processes are correct. Sometimes the aluminum will be formed into different shapes. You don't want it to crack. Like cans, a car door, you want it to hold its shape, be just as strong. For this process, we will be bending a sample and checking it out underneath the microscope and grading it. There's pass and fail, and so we do that with all of the metal that requires it to make sure that it's safe. This is the milling machine we use. We will take samples that have been cut from the shear, and then we will turn them into the dog bones that we are looking for to rip apart on the tensile tester. The final step is where we would measure it on the tensile tester to get the mechanical properties we're looking for. Basically, that is just how strong it is before it breaks. Because it's a destructive test, you're pulling apart the metal, and at its breaking point, it will tell you the yield strength, ultimate tensile strength, elongation. The tensile tester is automated, which is amazing. The more computers and less input you have via operator takes away variability and also removes human error from the process. Initially, I was good at math and science, so I wanted to go into engineering. I went to Missouri Science and Technology for school, and they had an intro session for a lot of different types of engineering. I was introduced to metallurgical engineering via a lab, and it was a lot of fun, a lot of hands-on, and I clicked. It's good to find different clubs that you wouldn't normally think to try out, because you'll meet new people. You'll see if you like something that's out of your comfort zone. It's always just good just to try new things. I enjoyed the department, got involved with school clubs that were related to casting as much as possible, got into hands-on student research work, and then I just kept going with it and graduated and looked for a job in metallurgy. Because I like making money.
Sweet! I like how there's automation even in the testing phase.
And she gets to see if everything's working or not all along the way.
Absolutely. Now, I'm more of a big picture guy myself, so I'll freely admit I need to develop better attention to detail.
Fair enough. And I know I need to find subjects I'm passionate about. Maybe they'll lead me to a career one day too.
Looks like we both have a lot of things we want to work on.
Absolutely. And that's a good thing. Definitely beats just going with the flow.
At the very least, our avatars look a little better outfitted for the future than when we started.
We want to say thank you to the entire team at Arconic for making this virtual field trip possible. We're so glad to have had the chance to be your guide through their advanced manufacturing operations in Tennessee.
And we especially want to send some gratitude to Shaquana Moore, Boubacar Maiga, and Laurel Black for guiding us through the awesome things they do.
And for giving us an overview of their unique career paths.
Remember, it's not a bad idea to start thinking now about what you want to do for a career.
Develop a plan and set it in motion. These can be small things, like taking that extra science elective, joining the robotics team, or working as an intern in a field that interests you over the summer.
Take some time to do a self-inventory. Ask yourself what you really like doing and what you don't, what you're good at and what you're not so good at. An honest inventory can be a great jumping-off place to start designing the future self you want to be.
Even if you feel you're not exactly awesome yet at what you might like to do for a career, you can always develop and master new skills if you work at it.
Just activate a growth mindset and keep moving forward.
There are so many great tools to check out at manufactureyourfuture.com, like a career guide for exploring the impressive array of jobs and careers in advanced manufacturing.
And surveys that will help you match your interest with different manufacturing careers. There's even a handy breakdown of the kinds of training each career path typically requires.
Need a little more background first? The self-paced module is your friend.
You can find out how technologies like robotics and automation are deployed throughout advanced manufacturing to solve complex problems and improve people's lives.
So be sure to visit manufactureyourfuture.com to access these and other great resources.
Thanks for taking this journey with us through the world of advanced manufacturing.
All of us at Arconic Foundation and Discovery Education wish you luck and success as you begin to manufacture your future self. So long, everyone!